Hi, this is Tim McCaskey, and I'm making a second attempt to film some data for the Kundt tube lab, trying to get some better sound and better picture. And I want to explain a little better what the phenomenon is. Now, I have this dust tube here and a ruler for reference. There's a speaker on the end, which I can control the frequency of. Now, before I show off any measurements, here's what I want to explain about it. This tube will allow antinodes to be visible. Now what you'll see when you turn this up loud is the dust will hop up. And the center of each of these spots is an antinode. You will see little stripes of dust hop up within those regions, but those themselves are not antinodes. So I chose a frequency around the middle of the range for this experiment, and I'll point out some antinodes here. So let me turn this up. We'll get very loud. Okay. You can see the remnants of those patterns a little bit, and I hope you saw the little stripes I was talking about. Here, I might say the ruler reading is around the 40 centimeter mark. That's the middle of this large patch that I will make fill the screen approximately. 40 centimeters is where that is, and then the middle of this one would be about 52 centimeters, and the middle of this one would be around the 62 centimeter mark. So I would say that those antinodes are, for this example, between 10 and 12 centimeters apart. The separation between antinodes is 1/2 of the wavelength. So the goal of the experiment is to, on one single trial for a given frequency, figure out the spacing of several antinodes and kind of average them out. So what I'm going to do is I'm going to play a number of frequencies, and I will give you an up-close look at two antinodes that are far apart, and I'll give you an idea also how many antinode gaps there are, so you can find the average one, or the size of an average antinode gap. All right. So let's start that, and I will I'll edit this where appropriate. Okay, let's give this a shot. So the default frequency this generator makes is 1,000 hertz. That's a good one to start with. Let's try it. Okay, so here's one antinode region. Read the middle of that. And let's count some gaps. There's one gap. There's 2, 3, 4. Okay. So I believe what I found there was 5 different antinodes. There's this one, this one, this one, this one, and this one. So it's important to note where the most distant one is and where the first one is. Hopefully you saw those clearly. And that was about 4 antinode to antinode spacings. That's what we need for 1,000 hertz. Now, let me adjust for a new frequency. Okay, this is 1250 hertz. Worked a little better than 1200, so here's one. So one antinode is in the middle of this. There's the next one. 3 antinodes, so 2 gaps. 4 antinodes, 3 gaps. 5 antinodes, 4 gaps. And this is where the 6th antinode is approximately. So if you record where that's located compared to where the first one was, which was around back here. Okay. We were measuring about 5 gaps that time. We'll try a new frequency. We have 1400 hertz here. Let's try it. Okay, that's the first one. That's 1 gap away. That's 2. That's 3. That's 4 gaps away. That's the 5th antinode. Let that be the last one. I believe I caught 6 antinodes for 5 total gaps. We'll compare the location of the first one and the last one that I showed. Okay, let's adjust the frequency again. Okay, I cut off my last video. I'm going to put these two together, and I'll start right away with 1600 hertz. You'll notice the antinodes are much closer together as the frequency goes up. So here's one. That's one antinode region. Okay, so let's count some gaps. That's 1 gap covered, the 2nd antinode. 2 gaps. 3 gaps. That's the 4th antinode I'm looking at. 4 gaps. 5 gaps. 6. 7 gaps. I'm going to stop there. That's the 8th antinode I've looked at, and so that's 7 gaps of distance covered between here and all the way back here. Okay, I have 1800 hertz set up. Let's take a look at those. These should be really close together now. And there's the first antinode region. So let's count some gaps. There's another antinode, so that's 1 gap. 2 gaps. 3. 4. 5. So this is the 6th antinode at this frequency, so I've covered 5 antinode gaps. 6 gaps. 7. 8. So this should be the 9th antinode that I filmed, and so that means I've covered 8 gaps from the first one to here. So you can find the size of the average gap. Okay, last trial. I'm going to try 2000 hertz. These will be the closest antinodes. Again, we're taking note of where the first antinode is and where the last one is, and how many gaps of antinode to antinode am I covering in all of this space. So here we go. There's the first antinode. 1 gap, 2 antinodes. 1 gap, 2 gaps, 3 gaps, 4 gaps, 5, 6, 7, 8, C10. So this is the 10th antinode and the 9th gap. If you make note of where this 10th antinode is, it is 9 antinode gaps away from the first one. And that should be it. Just as a simple check you can do for any of these, if I go back to 1,000 hertz, which I will do now, okay, so there's 1,000 hertz. If I measure the distance between one antinode and another one 2 gaps away, that should be approximately 1 wavelength. So let's test that real quick. So that antinode is at about the 15 centimeter mark. I'll skip this one. This antinode is at about the 49 centimeter mark. Okay, so I had one antinode at the 49 centimeter mark, one antinode at the 15 centimeter mark. There's one I skipped in the middle. That means I'm doing 2 antinode gaps. And that should be 1 wavelength. So because I measured them at 15 centimeters and 49 centimeters, approximately is where that was, right, 2 antinode gaps is 34 centimeters, which is about the wavelength I expect for 1,000 hertz, if the speed of sound is around 344 meters per second. I'm also going to edit this out, but I will also measure the temperature in the room. That's part of the lab as well. Okay, take a look if you can. All right, this is a Celsius thermometer, and the heat must be on fairly low because the temperature is about 20 or 21 degrees. Right, that's all the data I want. Right, I hope you understand what I'm going for here. We want to measure the average gap between antinodes. So the goal is to measure the distance between 2 antinodes that are far apart and then count the number of gaps between them. A wavelength is double the size of 1 average gap. Okay, that's all. Hope this works for you.